All right, hey guys, welcome back for day 1 of lesson 9.2. Our goals today are to talk about standard position, terminal angles, and conversions. Okay, or coterminal angles and conversions. All right, so first off, an angle is considered in standard position when its vertex is at the origin. Sorry. Okay. Come on. Hold on a second. That'll stop in a minute. Go upstairs with the dog, please. Okay, so let's start that again. An angle is in standard position when its vertex is at the origin. So you can see this angle here. Its vertex is at the origin. And its initial side lies on the positive x-axis. So here I have my x-axis. This is the positive x-axis because over here is my negative x-axis. And the red is my initial side of my angle. The blue is what we call the terminal side, okay? The initial side is locked. So the initial side is going to stay on the positive x-axis. The terminal side, the blue one, is the one that is going to move. It's going to open either clockwise or counterclockwise, okay? And that leads me to the next point. If we move counterclockwise, and counterclockwise is the opposite direction that the arms on a clock go. So moving counterclockwise would be spinning this direction, like I have here. That is positive. If I move if I move clockwise, if I go the direction that the hands on a clock move, that is a negative degree, okay? Also, these Roman numerals, just in case you forget, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right. So the first example we're going to look at today is we're going to sketch an angle with the given measurement and standard position. So this is to practice knowing that your vertex has to be at the origin. The initial side is locked to the positive x-axis. And then knowing negative versus positive, which direction does my terminal side go, all right? So I can get started with my 300-degree angle. Here is my vertex, and my initial side is locked. And then since it's positive, which direction do I want to turn? I want my terminal, my terminal side to swing counterclockwise. So I'm going to go this direction here. All right, if I rotate 90 degrees, I rotate another 90, so I'm up to 180. Another 90 is 270. All right, so then 270 plus what will give me 300? I need to go just another 30 degrees. All right, so we're just going to approximate where it would be, somewhere around here. And to indicate which direction I turned, I'm going to draw this little arrow indicating, and I'm also going to label it 300 degrees. Okay, so that is an example of an angle in standard position that's 300 degrees. All right, next I'm going to rotate negative 160. So again, I start with my vertex at the origin and my initial side locked to the positive x-axis. Okay. And since it's negative 160, that means I want to move clockwise. So my terminal side is going to rotate this direction. So I rotate 90, and then I don't want to go all the way to 180. I only want to go 160. So if this would be 180, how much less do I need to go? It's like 20 degrees less, right? So it's approximately, we'll say like here. And again, to indicate which direction I turned, I can go, or I can show by drawing my arrow, negative 160. All right. And then finally, positive 750. All right. So I'm going to start with my initial side on the positive x-axis. It's a positive 750. So which direction do I want to go? I want to turn counterclockwise. All right, so now we just do a little bit of math. If I rotate 360 degrees, a full circle, and then another 360 degrees, all right, so what's 360 plus 360? That'll get us to 720. So 2 full circles is 720. And then how much further do I have to go after 2 full circles if I'm at 720? How much further do I have to go to get to 750? I just have to go 30 degrees more. So I know that that's 750 rather than just 30? We're actually going to talk about that in a second, 750 and 30. Keep that relationship in mind. All right, I know it's 750 because I went one full circle, a second full circle, and then a little bit more to get to 750. So drawing those loops, those arrows, is important because it's indicating how big the angle is. Okay? All right, so let's talk about this for a second. All right, notice that this angle that we said is 750 degrees is actually the same as a 30-degree angle, right? If I asked you to draw a 30-degree angle, it would be there as well. Because remember, after we did 720, we went 30 degrees more. All right, so 750 degrees and 30 degrees, their terminal sides stop at the same position, right? Your terminal side, if I went 30 degrees, would be there. Your terminal side for 750 also landed there. So when that happens, they're considered coterminal angles. All right, coterminal angles are angles whose terminal sides land in the same spot. Okay, so that's what our next example is going to be. So let me erase and get that set up for us. Okay, so the next example says find one positive and one negative angle that are coterminal with the given angle. Okay. All right, so I'm going to give you two different ones. Negative 75 degrees and 460 degrees. Okay. So again, I want to think negative 75 degrees, where does that terminal side land? And what's an angle whose terminal side lands in that same spot? Now I could sketch it like I did for the last examples, but try to think algebraically. What are you doing to find an angle whose terminal side lands in the same spot? Can you just add a whole full circle to whatever angle is given? If you rotate and then rotate a whole full circle again, wouldn't you land in the same spot? So that's all you have to do. That's the trick for these problems. All you have to do is add or subtract 360 repeatedly. So I'll write that trick up here. For these types of problems, you're just going to add or subtract 360 degrees repeatedly. Okay. So if I give you an angle of negative 75 and you add 360 to it, is that going to give you a positive angle measurement? It will. Okay, so negative 75 plus 360 gives you a positive 285. Now, if I wanted another positive coterminal angle, I could just add another full circle, another 360 to 285, but I'm only asking for one positive. All right, I also want one negative, so I take the given angle and I subtract 360 from it. Is that going to give me a negative angle measurement? It will. Negative 75 minus 360 is negative 435. So that is another coterminal angle. All right, if I was to sketch this angle, that angle, their terminal sides all land in the same spot. All right. Now for 460, okay, same thing. If I take 460 and I add 360 to it, is that going to give me a positive It will. Okay, so add 360 to 460, and you get 820. Now, if you take 460 and you subtract 360, 460 minus 360, is that going to give me a negative? It's not. It's actually going to give me a positive. So I could have used this as my positive. I didn't have to do this. I could have used that. But what I'm going to have to do in order to get that one negative is subtract another full circle. So keep on rotating, subtract another full circle until you get that negative terminal angle that we're looking for. That's going to be negative 260. So again, 460, 820, 100, negative 260. If I sketched all four of those angles, their terminal sides would land in the exact same spot, and they are called coterminal angles. Okay? All right, let me introduce you to radians now, so give me a second to get set up. Okay, so radians is a measure of an angle. So, for example, if we were to measure a segment, we could measure a segment using inches. We could use centimeters, right? We have different units of measure when measuring the length of something. Well, we have different units of measure when measuring an angle as well. Now, we are very familiar with degrees. That's what we've always worked with. All your right triangle work that you've done has always been in degree mode, right? So we're very comfortable measuring an angle and looking at an angle and thinking of it in terms of degrees, in terms of a full circle being 360 and what portion that is of a full circle. However, we're going to start working in radian mode as well. All right, so angles can be measured in radians, and 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. So I'm going to write that down because that's important, and then I have some facts to give you before we jump into our first problem. So 1 radian is the measure of the angle in standard position whose terminal side intercepts an arc of length r. Okay. So if we have our initial side locked to the positive x and our terminal side and then talks about an arc length, so I'm going to draw a circle. So, and here's theta, here's my angle. So again, it says 1 radian is the measure of an angle in standard position. There's an angle in standard position whose terminal side intercepts a length of, an arc of length r. So I'm going to label this r. Okay. We also have our radius of the circle, r. All right. So if r is equal to 1, circumference equals 2 pi r, right? The circumference of a circle is 2 times pi times the radius, which if r is equal to 1, that means that c is equal to 2 pi. All right, therefore, 360 degrees is equal to 2 pi radians. All right, we just said the circumference of a circle is 2 pi. So 360 degrees, a full circle, is equal to 2 pi radians. All right, now if I divide 360 in half and get 180, and I divide 2 pi in half, I'm going to get pi radians. So 180 degrees is the same as pi radians. All right, so those are important facts to know. Two others that I'll list for you. 1 degree is equal to pi divided by 180. Let's think about that for a second. If I divide 180 by 180, I'm going to get 1. So you have to divide pi by 180. So pi over 180 radians. And we're going to use this conversion factor to go back and forth between radians and degrees. And then finally, 57 degrees is approximately 180 over pi, which is 1 radian. We don't really use this fact very often, but it's good to know, just so you know, if we know 1 degree is pi over 80 radians, then we should also know that 1 radian is equal to approximately 57 degrees. Okay? All right, so now we're going to convert from degrees to radians. And like I said, we're going to be using this conversion factor or this one. And I'll explain to you, how do you know which one you're going to use? All right, I'll explain that to you once I get the problem set up. All right, so this is, I think, the last bit of information for this lesson. Okay, so to convert from degree to radian, all right, so if you're trying to go from degree to radian, you're going to multiply by pi over 180. If you're trying to convert from radian to degree, you're going to multiply by the reciprocal. And it's actually easy to remember which one to use once you see the problems. Okay? So I'm going to ask you to convert the first problem is going to be negative 150 degrees. The second problem is going to be 9 pi over 4. And then the third one is going to be 2. All right, so the first one, if we're in degrees and we want to go to radians, I'm going to multiply by pi over 180. Now, the way I'm going to remember that is when you convert, and you might think about chemistry for this problem, when you convert, you always want your units that you're getting rid of to cancel by being diagonal from one another, right? So if I'm trying to get rid of degrees and go into radians, I want to get rid of the degree symbol, so I want them to be diagonal from one another, okay? All right, so then when I multiply, I'm going to multiply numerators and denominators, so I have negative 150 pi over 180, and then I need to simplify, so I'm going to simplify by crossing off the zeros just to quickly get started, and then 15 over 18 simplifies to 5 over 6. So I'm left with negative 5 pi over 6. And that's in radians. Okay? If you're in radians, you don't have to write the word radians. But if you're in degrees, you must put the degree symbol. All right? Okay, the next one. This is in radians, and I know it's in radians, hint, hint, because there's a pi symbol, but also because there's no degree symbol. Okay, so if I want to go from radians to degrees, I'm going to multiply by 180 over pi. And again, the trick for this is if I want to get rid of radians, if I want to get out of radians, I want the pi's to cancel. All right, so if you want the pi's to cancel, the pi has to be in the denominator for your conversion factor. All right, so the pi's are going to cancel, and then you're going to multiply, and you can always cross simplify before you multiply if you want, okay? But when you multiply and simplify, you're going to be left with 405 degrees. Again, you must put the degree symbol when you're in degrees. And then finally, 2. Well, is this in radians or is this in degrees? Is there a degree symbol next to it? There is not a degree symbol next to it, so that means you're in radians. So I want to go from radians to degrees, so I'm going to multiply by 180 over pi. So you're going to have 2 times 180 degrees over pi. All right. So when you get, or when you multiply, you're going to get 360 over pi. And since we want to be in degrees, we're not going to have that pi symbol in there. So you're actually going to take your calculator and divide 360 divided by pi. Use your pi symbol on your calculator. And you're going to get 114.59 degrees. All right, guys, that is it for day 1 of lesson 9.2. Jump online, get your homework done, and I'll see you back here for day 2. Bye.